Hi. This week we're going to consider a couple of extensions of what we learned about the second order differential equation, and we're going to be moving these extensions in various different ways. We're going to start with what do we do when we have differential equations with variable term. And I hope you remember from dynamic economic analysis that we actually already considered a method of dealing with this situation. This is a method of undetermined coefficients. Okay, so look, what do we have here? We have a differential equation as we had thus far. So we have on the left hand side, because we have second order differential equation with constant coefficients. However, the new thing that appears over here is variable term. Why do we get into consideration of variable term here? Look, in economic applications, there are some specific functions that we would like to be able to place over here. And of course, once we are placing them here, we would like to know how to deal with this case. Well, we already dealt with this in case of first order differential equation. So let's just do one example that should illustrate the entire process of dealing with such a case. Okay, so let's just say the differential equation for which we need to find a particular integral is given by y piece plus a1, plus 5y prime plus 3y equals to 6t squared minus t minus 1. Okay, so look, in cases like that, what we can do is to try to guess what combination of a function, first derivative and second derivative, would give us this expression. And of course, when we think about it, if we take quadratic function that we see over here, if we differentiate it, we're going to have a function that is linear. And if I'm going to differentiate again, I'm just going to have a constant, right? And look, all those things are over here. So maybe we can try to have particular integral to be a quadratic function. And this is the way we're going to go about it. So we can start by assuming that yt is some b1 t squared plus b2 t plus b3 quadratic function. Now, what I can do with this, of course, what I need to do with this is to differentiate. Then I'm going to get that this is 2b1 t plus b2, and then I calculate the second derivative, which happens to be just 2b1. And look, if I'm going to combine those three results, I'm going to get actually an expression very similar to this one. Okay, so let's try it. So what we are going to do now is to take those three results and substitute them into the equation we've got over here. Okay, so we've got equation y piece plus 5y prime plus 3y. Okay, so let's start. First, we need to substitute y piece, right? This is easy, just 2b1. Then plus 5 times y prime, right? So this is easy, we just multiply by 5 this entire expression. So we get that this is 10b b1t plus 5b2. Okay, and finally we need to substitute 3 times y, right? So we're going to get that this is plus 3 times b1t squared plus 3 times b2t plus 3b3. Okay, and look, I know that at this moment, this does not resemble that, right? But we are just one step away from it. Why? Because look, I can collect different terms that have the same expression with t. So look, we've got just one expression with t squared, right? So we're going to start with this one, right? I'm going to put it here. 3b1t squared and plus. Okay, we've got 2 expressions with just t, right? So I can write again that now this is equal to 10b1 plus 3b2 t. Right? And finally, we've got 3 expressions without t. Right? So I can also write it as 2b1 plus 5b2 plus 3b3. Okay, and look, now we know that this, right? So left hand side is equal to right hand side in both of the cases. So what do we get from this? Look, we get that this should be equal to 6, right? The coefficient on here should be equal to 6. This should be equal to -1, and this should also be equal to -1, right? Okay, and now look, calculation from this moment on is really straightforward. Look, we've got that 3b1 must be equal to 6. So right away we get that b1 is equal to 2. And this is our first result. Okay, from this we get that 10b1 plus 3b2 is equal to -1. However, we already know that b1 is equal to 2. So we've got 20 plus 3b2 equals to -1, 3b2 equals to -21, or b2 equals to -7. Okay, and this is how we get our result number 2. Finally, we know that 2b1 plus 5b2 plus 3b3 is equal to -1, right? Okay, but we already know that b1 is 2, so here we've got 4. We know that b2 is equal to -7, so we've got -35. Then we've got plus 3b3 equals to -1. Okay, so out of this we've got -31, so -30. We've got -31. So we've got 3b3 equals to 30, or b3 equals to 10. And this gives us our final result. Okay, so we can see that actually all we've got to do now is to substitute appropriate coefficients over here. And we get that particular integral in this case, is a moving equilibrium, and it's given by 2t squared minus 7t and plus 10. Okay, and look, this gives us our final solution. So, as long as we've got a situation in which we can find derivatives, consecutive derivatives of these functions, of the functions that we've got over here, we will be able to use the method of undetermined coefficients to find particular integral. However, there is a catch to it. It's not very problematic because we know how to solve it right away, but sometimes it might seem that this could mean a big problem for us. Okay, look, imagine that situation over here changes and we are losing 3y. Okay, so what should be our trial solution? Look, let's try this one first. So, trial solution. Again, we can try b1 t squared plus b2 t plus b3. Okay, let's think about it. Look, is it possible to get y equal to this, and then the second two derivatives would be equal to this expression? Well, it's impossible. Why? Look, if I'm gonna put here first derivative, calculate the first derivative, we see that it's going to be 2b1t plus b2. We right away know that something is wrong. Why? Well, if I'm going to also calculate the second derivative, right, I'm going to have 2b1. Look, what would we get after substitution of these two? Right? Would be component associated with t, with a constant, but there's no anything with t squared. So this solution will definitely not work because we are one derivative, because we are one expression short, because after differentiation we will get this. How can we fix it? Look, there is a simple way to fix it. The way we used actually even with complementary function is just to increase the degree of the polynomial. Look, if I'm going to multiply this by t, what am I going to get? Well, each of these expressions are going to end up here with a different power. Okay, look, after multiplication, we're going to get b1t to the power of 3 plus b2t squared plus b3t. So, first derivative is going to be 3b1t squared plus 2b2t plus b3. And the second derivative is going to be 6b1t plus 2b2. And look, if I'm going to substitute those two over here, again, I'm going to be able to obtain over here expression that has t squared, t, and constants. So, the trick, if we are missing the expression for this for the function itself, for y, is to multiply everything by t. Okay, but let's go one step further. So what would we do if it turns out that our equation looks like this? Well, again, this trial solution is not going to work. But I hope at this moment, you know what we should do. We need to multiply the trial solution by t squared. And again, look, after two differentiations, expression with t to the power of 4 will turn into square, and we will be able to use method of undetermined coefficients exactly the way we did. Okay, I believe that this is everything you need to know about method of undetermined coefficients. In the next video, we're going to see how what we learned about second order differential equations with constant coefficients and variable term can be used, how it can be used to bring us closer into modeling GDP and actually business cycles. Okay, thank you for your attention and see you in the next video.